Hey guys, how you doing? So today we're taking the next step. So if you notice, we keep getting a little bit more complicated each time. We keep changing one thing slightly. So today what we're going to do is instead of looking at linear functions only, we're going to be looking at linear functions and nonlinear functions. So a nonlinear function, common sense tells you it is not linear. Okay. So a linear function, it graphs a constant rate of change. Okay, hence the reason why it's called linear or a line. So that means every time it either moves up and then to the right or down and to the right, every time you make a step, it's the same exact proportion. That's what it means is a constant rate of change. A nonlinear does not show a constant rate of change. So there are a lot of different, let me move myself out of the way. There's a lot of different functions that most of the functions are actually nonlinear. But so for example, for this one, oops, sorry, I clicked on something. Here you go up one and to the right one, but then the next one is you're going, the next time you move over one, you're going up like 2.5. Okay, so it's a little bit different. So each time, then let's say you went over one more time, you're going up like 7 or 8. Okay, and that's going to keep changing each point. So this is, you're going to get into these when you get into Algebra 1, Algebra 2 the next couple of years. So this is just the very beginning of it. So this is x squared, just so you guys know. It's a little bit different. So this is y equals x. This is y equals x squared minus 1, but you don't need to know about it. So it's a squared x. This is a cube, okay, x cube. This is something cool. You'll get to this probably maybe as a junior or senior. You're actually graphing something called the trigonometric function. And it makes little flowers. It's kind of neat. Okay. So first part you're going to do is be able to identify, is it a linear or nonlinear function from a table? Okay, so you guys have been doing this in the past. That's why I was like, let's really focus on it the last couple of days. So what it does is each time you go from one point to the next, there's a common ratio. So in this case, it's very consistent, and it doesn't always have to be like this. We'll see that in a second. But it keeps going up by 3, right? And each x goes up by 3, and each y goes down by -8. So that, if I were to do y2 minus y1, x2 minus x1, or over x2 minus x1, you're going to notice that it's going to come out to be -8/3 every single time. Okay. This one is different. Let me move myself up a little bit. Okay. Because, and again, this one kept the x consistent each time. X keeps going up by 2, but you notice y keeps changing every single time. That just means that this is a nonlinear function, right? So when you graph it, it's going to come out to be something totally different. Okay. Now, you're going to have to be careful because tables can be deceiving. Okay, this might be a linear, it might not be, but you notice my x's are changing each time. This one goes up by 3, this one goes up by 2, this one goes up by 4, this one goes up by 6. So what? Okay. This one keeps going each time. So don't let that bother you. What happens is it's the change in y divided by the change in x. And as long as it's consistent, you're going to be okay. Move this up here. Okay. So you pick 2 points, and you're basically, you're finding the slope. If it's a consistent slope, therefore it's linear. If it's not a consistent slope, it just means it's not linear. So let's just take, I chose this one, 20, 720, and 210. Okay, so 20 minus 10 over 7 minus 2 is going to be 10 over 5, right? So that's a difference of 10. That's a difference of 5. So that would be a ratio of 2 to 1 or 2. Now let me pick 2 different points, totally different points. Let's do 28 and 16. So 28 minus 16 happens to be 12, and now we do my x2 minus x1, so 11 minus 5 is 6, and 12 minus 6, 12 divided by 6 is 2. Because when I picked 2 different points and I got the exact same answer, it's linear. Okay. If they weren't the exact same number each time, it just wouldn't be linear. That's all. Okay. The next one is we're going to try to identify functions, whether it's linear or nonlinear, from their equation. So if you guys remember, a linear equation is in the form y equals mx plus b. So here y equals 4 times x minus 1. Well, we also learned that if you can get it into the form y equals mx plus b, you're going to be fine. So this one is because if I were to use the distributive property, multiply the 4 to both of them, I'm going to get y equals 4x minus 4. Therefore, it's in that form, and it's linear. Sorry, got to move myself over here. Now let's look at the other one. Y equals 4 over x. Is this linear or nonlinear? It's nonlinear because there's no way I can get this into y equals mx plus b, because here the x is in the denominator. Here, technically, the x is in the numerator. Technically. Because remember, for every whole number, you can rewrite every whole number as a fraction, something over 1. So if a variable is in the denominator, you can see it's going to be in the line. Other than that, you're always going to assume it's in the numerator, even if there's nothing underneath it. So here, I cannot make it. This would be, y equals whatever over x. So it's not always going to be a constant rate of change. Therefore, this is nonlinear. That's all it means. We're just looking at, is it linear? Is it nonlinear? We're not going too much more in depth than that for right now. I think you guys can figure this one out. Clearly, it's linear. Okay. Now let's look at this one. Y equals 4x over 3. Is that linear or nonlinear? Okay. Well, x happens to be in the numerator, therefore it is linear. Why is that? Okay. Because what is the slope here? Remember, 4x over 3 is actually, we can rewrite that as a multiplication problem of x times 4/3. Right? And now x times 4/3, or y equals 4/3 x, that's in the form y equals mx plus b, because what is it? It's really plus 0, but here's your slope, 4/3, multiplied it by x. Right? Now we get to something that's a little bit different. You notice I have a square. All right? So there's 1 minus x squared. This is nonlinear. And the reason why is, in order for it to be linear, x has to have a variable, or an x, I'm sorry, x has to have an exponent of 1. Go back for a sec. Okay, so this is x to the first. Okay, x to the first, y to the first. We know that. We learned about that, well, not with me, but should have learned that last year in 6th grade, even in 5th grade, where the exponent, if it is not there, it's automatically assumed to be 1. Just like the coefficient here. The coefficient before x here is 1, right? Because we don't have to write it. If it's not written, it's understood to be 1. So here we have a variable with an exponent of 2. Okay, and anytime you have an exponent of anything bigger than 2, bigger than 1 or less than 1, it ain't linear, right? So this would actually be, it's called the parabola upside down. Okay. Normally it's up, but there's a little minus in front of it, so that changes it. That's kind of a cool thing. You're going to do that in Algebra 1 next year a little bit. Okay. So this would just be a nonlinear function. So now let's look at a situation of something like this. So two accounts have different types of interest. The table shows the balances of each account for 5 years. Graph the data and compare the balances over the time. Right, so obviously you can see this goes up by 1. This is going up by 10 each time. So since this is consistent and this is consistent, it goes up by 10 for each one. A is going to be linear, and you'll see that in a second when we graph it. If you look at B, this one goes up by 10. Then this goes up by 11. Then it goes up by 12.1. Then it goes up by 13.31, so on and so forth. So if you were to graph it, it actually would be different. Okay, it's curving up. So this is linear. This is curving as it goes up. So what we can determine from this is A is a linear function. B is a nonlinear function. That's all we're really looking at. And this is actually more of what you want. This is what people look for in money. As opposed to something going up consistently, they want it to grow. This is called exponentially. We've talked a lot about that, especially with, well, we haven't, but you've seen a lot of it with coronavirus and all that kind of stuff, like flatten the curve. Like this is the kind of things they're talking about. It curves up, and they're trying to curve something back down. But when we're talking about money, you just want to keep curving up and 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 up. Hasn't really happened with the stock market over the last couple of months, but that's another story. Okay. So if you guys have any questions, please reach out to me. I'll have chat on with GoGuardian. All right, good luck. Bye.